Hi everyone. So today we are going to be solving quadratics by completing the square. So we're going to be using that completing the square skill that we've been working on. All right, so pause the video and do the do now. So we have 49x squared minus 144 equals 0. We always get 0 on one side. Factor. Difference of two perfect squares equals 0. So we get x equals negative 12 over 7 and x equals positive 12 over 7. For this one, I'm going to add the 2x and subtract the 4. 2x squared. All right, so we get 0 equals, 3x squared plus 11x minus 4. I'm going to factor it in my head because I automatically notice that 3 times 4 is 12, which gets you very close to 11. And if we subtract 1, we get 12 minus 1 is 11. So then I get x equals 1/3 and x equals negative 4. All right, so pause the video and do these practice completing the square problems. All right, so first one, x plus half of 10 is 5, so it's 5 squared. And then I add that extra 25 is in the problem, so then I subtract it, combine it with negative 1. X plus 5 squared minus 26. For this one, we have to divide by 4 first. We get x squared minus 2x minus 5 over 2. When I simplify, 10 over 4 is 5 over 2. So now I'm going to ignore the 4 for a second. The inside, I have a 2. So that's x minus 1 squared. We have an extra 1 in there, so minus 1 minus 5 over 2. That is x minus 1 minus 7 over 2. We then have to multiply through by that 4. And we get 4 x minus 1 squared minus 14. 4 times 7 over 2 is 28 over 2, which is 14. All right, got some decimals now. So x plus half of 5, 5 over 2 squared, minus square the 5 over 2, you get 25 over 4. And then I'm going to write 2 with a common denominator of 4, 8 over 4. So my answer is x plus 5 over 2 squared minus 33 over 4. So next one, I have to divide again. I'm going to divide out a negative 2. X squared minus 11x plus 8. Oops. Half of 11, x minus 11 over 2. And then 11 squared is 121 over 4. And then plus 4 on the bottom. I'm turning 8 with a denominator of 4 is 32. What is that? 121 minus 32. 989. So that's x minus 11 over 2. Sorry, that's really, that looks terrible. 11 over 2 squared minus 89 over 4, and then we have to put the negative 2 back in the problem. So negative 2, x minus 11 over 2 squared minus 89 over 2. And that is my answer. All right, so now we're going to get down to the gross ones. So when I divide by 4, I've got x squared plus 7 over 4, x minus 4. That's x plus 7 over 8. Half of 7 over 4, 7 over 8 squared, minus, I have to square the 7 over 8. I get 49 over 64 minus 64. I have to turn the 4, needs a common denominator. So 64 times 4 is, I'm going to say 2, I feel like I should know this. 64 times 16 squared, 256. And then we're adding, so that becomes negative, let's see, 5, carry the 1, 305. So we end up with 4, x plus 7 over 8 squared, minus 305, and then that 4 that we put back into the problem, that's right here, cancels that with a 64 to give us 16. Yes, I do recognize that these are obnoxious problems. All right, number 6. Let's see if I can fit it on here. This is as bad as it gets. All right, number 6. We can't, I mean, unless I make the numbers way bigger, the process doesn't really get worse. Divide by 3. I dropped my x. Half of 8 over 3 is 8 over 6. 8 over 6 is 4/3. So 4 over 3 squared minus 16 over 9. Because 4 over 3 squared. And then we have to combine that with the 11 over 3. So 11 over 3. So I'm going to multiply times 3 times 3. So it's 33. So we have x minus 4 over 3 squared plus 17 over 9. Now I have to put the 3 back into the problem. So my final answer is 3 times x minus 4 over 3 squared plus 17 over 3. Whew. That's a little rough. I agree. All right, let's do a quick review of simplifying square roots. All right, so the idea with square roots, what is the largest perfect square that goes into 40? Hopefully you know it's 4 and 10. The square root of 4 times the square root of 10. Square root of 4 is 2. 2 root 10. 150. All right, so if you're not sure what it is, you can start writing stuff out. 2 times 75. 3 times 50. 4, 5 times 30. 6 times 25. So 25 is the perfect square that goes into 150. So I'm going to rewrite 150 as the square root of 25 times the square root of 6. 5 root 6. 72 is 2 times 36. So now we have the square root of 2, the square root of 36, and that 3 in front. So that's 3. Square root of 2 is just the square root of 2. Square root of 36 is 6. Multiply the outside numbers, and that is your answer. All right. Without subtracting, how could we solve for x here? So think of x squared. What is the opposite of squaring a number? It's square rooting it. So if we just take the square root of both sides, we get x equals. Now here's the tricky thing. It's actually plus or minus 5. So the square root of x squared is actually the absolute value of x, not just x. So when you solve the absolute value of x equals 5, remember you have to do x equals 5 and x equals negative 5. There's 2 answers. So typically what we do to avoid the whole square root thing, the absolute value thing, we just make sure to put plus or minus. Because if you square negative 5 squared, you get 25. All right, using that same process, let's solve number 5. Instead of subtracting the 169 and factoring, I'm going to divide by 4. X squared equals 169 over 4. And then I'm going to take the square root of both sides. When I take the square root of x squared, I have to put a plus minus. The square root of 169 is 13. And the square root of 4 is 2. Done. All right, so these, I already completed the square for these. So take a second, look at them. What do you think you're going to do to solve for x? Again, using square roots. Do not multiply out. Do not multiply out. These are not factorable problems. All right, so I'm going to add the 9. All right, because we're isolating the square. Now that I have the x minus 5 squared, I have to get rid of the square. The inverse of a square is a square root. Just like before, I need a plus or a minus. Plus or minus 3. Move the 5 to the other side. Now here's the trick. When I add 5 to both sides, be really careful. We have 5 plus or minus 3. So that's 5 plus 3 and 5 minus 3. So my two answers are 8 and 2. All right? You can't combine the 5. You can't do plus. It's not plus or minus 8. It doesn't work like that. All right, so now pause the video and do number 7 on your own. So same process. I move the 16. Once the square root is by itself, we take the square root of it, and we get plus or minus 4. Oops. Move the 2 to the other side. I always just put it in front. Negative 2 plus or minus 4. So I have negative 2 plus 4, which is 2, and negative 2 minus 4, which is negative 6. And that's our answer. Actually, these two, because they are integer answers, if we multiplied all that out, it would have been factorable. All right, these are not, though. All right, so I'm going to do this one with you. I'll do 8. You guys are going to do 9. All right, so same idea. But here, notice what's going to happen. I move that 10 to the other side. Square root of both sides. Do we know the square root of 10? We do not. So here's what we're going to do. X plus 8 equals plus or minus root 10. Subtract 8 on both sides. Negative 8 plus or minus root 10. And that's your answer. We're done. That is it. Do not combine that negative 8 with the root 10. Those do not go together. It's like 8 plus x. Can't do it. All right, try number 9 on your own. Pause the video. So I'm moving the 15. Square root of both sides. When you take the square root of an x, you have to put plus or minus. And then add 15 to both sides. So 15 plus or minus root 15. Done. All right. Now we're getting to the ones that we actually need to be able to do this with. So now here's the thing. If you try to factor, like pause the video, try to factor number 10. What multiplies to 20? 2 times 10, that's 12. 4 times 5 is 9. So this is not a factorable problem. So we've been using solving or factoring to solve. But what if it's not factorable? And that's why completing the square is important. Because if it's not factorable, you need to figure out another way to solve. And if we complete the square, it makes it a lot easier. All right, so this is a nice, easy completing the square problem. So x minus half of 10 is 5. We square 25, square 5 and get negative 25. And we have to combine that with the 20. So x minus 5 squared minus 5 equals 0. X minus 5 squared equals 5. Square root of both sides. X minus 5 equals plus or minus root 5. And then x equals 5 plus or minus root 5. So pretty much anytime it's not factorable, you're going to have a root in your answer. It's going to be some weird decimal. All right, try 11 on your own. Pause the video. All right, so half of 20 is 10, and then 10 squared is 100. So it's x squared. I'll show more work for this one. 20x plus 100. So that's x plus 10 squared. Then we do minus 100 plus 50. So that's minus 50 equals 0. Move the 50 over. Square root. Oh, I wrote the square root already. So x plus 10 equals plus or minus root 50. And then finally subtract the 10. Now, look at this for a second. I would actually take a point off on a quiz. Why would I take a point off? Because 50 has a perfect square in it. 50 is 25 times 2. Square root of 25 is 5. So negative 10 plus or minus 5 root 2. And that is your answer. All right. Let's try this one. So now you can move the 20 over. Usually students prefer to move the 20. It actually doesn't matter if you move it over or if you deal with it later, since we're going to move stuff to the other side anyways. Typically students, when they're learning this, prefer to move it. So let's move it. I'll do the next one without moving it. All right, so pause the video and do this one. So we get half of 16 is 8. 8 squared is 64. And then we have our minus 64 plus 4. So that's x plus 8 quantity squared minus 60 equals 0. So then we just moved it over anyways. X plus 8 squared equals 60. Square root. X plus 8 equals plus or minus root 60. And then simplify 60. 60 is 4 times 15. And I'm going to move the 8 over. So it's negative 8 plus or minus. The square root of 4 is 2 and root 15. So what a lot of teachers do when they teach this, they just automatically have you move they only have you have this on one side. And they move the 1, so they'll make this a 12. So then half of 14 is 7, so then you have x minus 7 squared. And then we have to subtract off that 49. X minus 7 squared equals 5961. Well, that's at least not a perfect square, so that's good. X minus 7 equals plus or minus root 61. 7 plus or minus root 61. So these really aren't that bad. It's only bad when you have a number in front of x squared. All right. Same idea. Pause the video. You should be able to do these on your own. All right. I'm going to move the 2 over. So x squared minus 5x. I'm just used to having it look like this. All right, so we've got fractions now. So x minus my 5 over 2 squared. So I have to square that. 25 over 4 minus 25 over 4 plus that 1 I'm going to turn into 4 over 4. So that's 21 over 4. And it's negative, so that's going to move to the other side. X minus 5 over 2 squared equals 21 over 4. Square root. Now, x minus 5 over 2 equals plus or minus. Now, since the 4 on the bottom is a perfect square, I'm going to make this the square root of 21 over 2. And then I can move the 5. X equals 5 over 2 plus or minus root 21 over 2. And it's pretty common to have that as one big fraction. You can do that too, or you can leave it. All right. So because this is an equation and not an expression, we're allowed to just divide the whole thing by 2. So I'm going to do that. So x squared plus 7 over 2x plus 4 equals 2. In my parentheses, half of 7 over 2 is 7 over 4. I'm going to move the 4 over to get negative 2. Square the 7 over 4. It has to be subtracted off, 49 over 16. So then we're going to add that to the other side, 49 over 16. And then 2, that's 32 over 16. So we get x plus 7 over 4 squared equals, what is that? 17 over 16. Square root of both sides. Again, the denominator, which is kind of nice, is a perfect square. So it's the square root of root 17 over 4. And then move the 7 over 4 over. I'm going to write this as one big fraction. It's negative 7 plus or minus root 17 all over 4. So you can put them both over 4, or you could write it like this. It's up to you. Oop, that was it. So now we have an activity. So you're going to work on the clue activity. I'm going to assign everyone a different page of it. It's 4 problems on each page. And then you're going to have some book work. All right. Have a great day, guys. Bye.